Hello, friends. Hope you are doing well. So, what data engineering syllabus we teach, and what is data engineering, and what data engineers do today, I will tell you about that. So, first, I will start with what is data engineering, and what is the importance of data engineering, and what do data engineers do, and what tools and skill sets they should have. So about data engineering is something is the process of designing and building systems that let people collect and analyze raw data from multiple sources and formats. These systems empower people to find practical applications of the data which business can use. Right. Let us suppose, by example, there's a company that has its head office in some place. Let us suppose that place is India, and there are multiple offices of the company in various states of India. So there's a project uh, that people are working on, the team is working on. So that project, suppose some data is with some team, some data is with some team. So in this, using the data process of this, we can collect the data from different teams and we can design and build system accordingly. This is first we can understand, and we can take as suppose the organization has different employees. So there the so the organization has to build the system for its employees also. So there also we can utilize this. Now, what is the importance of data engineering? The importance of data engineering is that companies of all sizes have huge amount of data to come through to answer critical business questions. Now, data engineering is designed to support this process by making it possible for consumers of the data, such as analysts, data scientists, and executives, to reliably, execute, and quickly and secure inspect all the data available. Now, let us take one example to better understand this properly. So, suppose there is one system maintaining the billing and shipping of the products as customers, and other system maintains the history, and other system stores the support. Other system supports the behavior information, third party data. This can be data of any huge stores such as Walmart or any any shop, Walmart is there, and in India we have DMarts and Geo was this Smart Bazaar is there, and all such examples are there. You can take the examples of VMart and other things. So these companies have different set of different data. So together, this data provides a comprehensive view of the customer. However, these different data sets are independent, which make answering certain questions like what type of orders result is the highest customer cost supports, what is the particular order that is the customer is liking in a particular area, in a particular state, what is the particular product that is selling in different area, different state. What is the most selling product, and what is the revenue generated in a month from different store. So data engineering answers these questions in a simple way. It unifies these data assets and lets you find the answers to these questions quickly and effectively. Now, what does data engineers do? Data engineers are the people who design these systems and unifies data to help us navigate through it, navigate through this data, and they perform different tasks such as acquisition, that finding different data sets around the business, cleaning, cleansing, finding the finding and cleaning any errors there in the data conversion, give all the data in a common format, disambiguation, interpreting data that could be interpreted in multiple ways, deduplication, remove duplicate data, and once this is done, data is stored in a central repository such as data lake or data lake house. And data engineers also maintain a copy and move subset of data into a data warehouse, so that if any irregularity is there, suppose by any chance there's a data loss, so by making a copy, we do not have to bother about that. If there is any data loss in the system, suppose any such situation happen, we do not have to bother about this, that we have lost our data. We had maintained a copy of it, and in this set of these data, so there's we do not bother about this thing. And now, why does data needs processing through the data engineering? See, data engineering plays a very crucial role in designing, operating, and supporting the increasingly complex environments that power modern data analytics. Historically, data engineers have carefully crafted data warehouse schemas, with table structures, indexes designed to process queries likely to ensure adequate performance. Now, with the rise of data lakes, data engineers have more data to manage and deliver to downstream data consumers for analytics. Now, we know that the data is huge. You know, the data that we are getting is huge. We cannot perform the analysis easily. So, what we do, we generally divide the data into the chunks, and we perform the analysis on these chunks. And whatever is the analysis, we perform the other operations accordingly. So now data is stored in data lakes, and they may be structured and unformatted, and it needs attention from data engineers before the business can drive value from it. So once the data, so so the data, we have to perform all the operations that I have told earlier. So once the data set has been fully formatted through data engineering, it is easier and faster to read and understand. Since the businesses are creating data constantly, it is important to find software that will automate some of these processes. Now the right software that will extract a huge amount of human value are data pipelines. Now, data pipelines are the thing, they create end-to-end journeys for data, and the information travels through the pipeline is transformed, enriched, and summarized several times. Now, the ETL process is performed here. This generally the ETL process extract transform is going to it is first extracted, and then it is transformed, and then it is loaded. This data processing is very important. And as I told you, it's very important. Now we will discuss about the tools and skills with, with the data engineers. Now tools and skills which the data engineers work with uh, work with the data are tools. The data engineer use many different tools to work with the data. They use a specialized skill set to create end-to-end data lines, and that moves the source system to target destinations. Suppose there are files which have which since there are files from one place to another, that can be done through this. And data engineers work with a variety of tools and technologies, including ATL tools. This is nothing but extract, transform, load. Move the data between the access data can then apply rules to transform data through steps. Remember, SQL. SQL is nothing but structured query language, which is used for querying the relational databases. Now, Python is general programming. Data engineers may use for ETL tasks. We also using PySpark for, and we are using RDD, resident distributed database. Depending on the project we are working, depending on the task we are given, we have to use the language accordingly. We can use Scala also. Now, cloud data storage, we have been using our Azure data lake storage, Google Cloud, Google Cloud Storage, Amazon S3, and the cloud platforms, AWS, Azure, and Microsoft Azure, and GCP. Now, query engines, which are commonly used uh, to return answer, the data engineers that are Spark, Flink, Dremo, Dremio, Sonar, and others are also there. So these are the commonly used tools. Now, what we are teaching in the data engineering, I will go through that, and I hope that you will get the complete to the syllabus which we are. I will discuss now. Get the complete uh, picture how the process will go, how you will study this data engineering from us. Now, the data engineering syllabus which we teach typically covers a range of topics related to design, construction, management of data pipelines, infrastructure to support data-driven applications and analytics. Now, first of all, we will teach Python. We will start with the introduction to Python, basic syntax, data types in Python, work with variables, operators, using built-in function libraries. Then the data manipulation with Python, list, tuples, dictionaries, conditional statements, and loop, user-defined functions, functions such as map, filter, and lambda. Complete exercises will be formed during the live sessions. Many problems will be discussed during the live sessions, and the recorded videos will be given also. Now, next is working on data with Python, data cleaning and processing with pandas, importing and exporting data, handling missing, removing duplicates, and deleting outliers. Now, then is the EDA. EDA is nothing but descriptive statistics and data summarization, grouping, SQL elaborations. Now, next is data visualization and matplotlib, creating basic plots, customizing and styling, visualization, creating, informating, aesthetically pleasing visualization, paper plots, heat maps. Next is data analysis in Python. Data analysis in Python is knowing about the data. Type of analysis, univariate, multivariate, bivariate, whatever analysis is. Then creating hypothesis or project approach. Introduction to statistical test and hypothesis testing. Implementing statistical tests in Python. Final project and case studies. Participant work on real data, data analysis projects, applying learn. Next is data pre-processing approach, feature engineering, feature selection. The data, data, whatever the recorded videos are there, data analysis, and then probability introduction to maths there, and data science, which is covers probability and statistics. Basic probability concepts are there, random variable probability distribution, statistical interference, hypothesis testing, regression analysis, then statistical analysis, Python measure uncertainty, dispersion, variation, correlation, ANOVA, and chi-square test, p-test. These things will be taught. P-test, t-test, z-test, these things. Then statistical analysis, SciPy, which covers statistical tests and hypothesis testing, implementing statistical tests. Python, starting with machine learning for supervised learn, which is classification, name base, kernel classifier, practical, decision tree, heuristic regression, practicals, SVM in practical, classical application, linear regression. Now, linear regression, the practical and branch types of linear regression, lasso and bridge, non-linear regression, unsupervised. Then we will cover unsupervised learning, which types of clustering model, enumeration, k-means plus algorithmic association rules, market basket analysis, advanced model optimization, ensemble method, ensemble technique, weighting, stacking, boosting, and backing, ensemble random forest, GBoost classifier, regressor, parameter tuning. Hyperparameter tuning involves model evaluation, optimization, cross validation. Types of cross validation is there. Hyperparameter tuning, hyper model section. Now, introduction. After this introduction to this data engineering, the first module in the data engineering, the data syllabus. This syllabus, which I am telling about, this is taught in the big data developer course or ours, the whole syllabus with Python and the some machine learning part. And now the syllabus which I will be discussing is the pure data engineering syllabus. Those who want to learn only the data engineering part without uh, learning Python will be without learning Python and the machine learning and the EDA concept and the data analysis and the EDA and the data visualization and the some part machine learning will not be studying. Those who have those who know that will start. We will start from this syllabus introduction to data engineering. Now, the data engineering syllabus, as I told you, it covers the whole concept of data engineering and explores the crucial role. It will really explore the crucial role the data engineers plays in the modern data landscape, including the significance and supporting data-driven decision making. And this completely covers the visualization and providing comprehensive overview of the process that are involved in handling data efficiently. Now, the overview of data engineering role, importance of data engineering versus data science. First, data analytics, data lifecycle, ingestion, storage process, and visualization. Data storage techniques. The module is the second step. This the data engineering syllabus, and it delves into the various data storage solutions, including relational databases, NoSQL data warehouses, and distributed file systems. Now, we will we will learn on the strength and weakness of each technology, how to design efficient storage systems, how to choose the appropriate solution based on the specific use cases. In depth, we will be learning about the relational databases, NoSQL databases, which is document key value for graph database, data warehouse, star, slope, snowflake, olap, OLTP, data marts, and distributed Hadoop, HDFS, Google Cloud Storage, Amazon S3. Data processing techniques are there. In this module, data processing paradigms such as batch processing, stream processing there. And this module explores how this technology enables efficient processing of data, whether in large batches or in real streams. Now, the technologies that help in achieving the data efficiently: batch processing, map reduce, Apache Spark, data parallelism, stream processing, Apache Kafka, Apache Flink, event-driven architectures in the memory Redis, Apache Ignite. The fourth module in data engineering syllabus will help you to study stack transform that are essential for integrating data. Now, here we will teach how to design and build ETL pipelines and data extraction techniques, data transformation methods, data integration tools that we teach Apache NFI and Informatica, data transformation, data cleaning, enrichment, aggregation, data modeling architecture. Now, data modeling techniques in this modules, the syllabus includes conceptual, logical, and physical module. This will be dimensional modeling. That will be modeling, and we will understand how to design efficient schemas such as star and snowflake. Data pipeline orchestration, and we in this we will learn about how the work management systems such as Airflow and which enables automation of orchestration of data pipelines, and how to schedule, monitor, and manage dependencies between tasks. Now, data quality and testing, we will discuss the data quality and testing part also. This module focuses on ensuring the quality it, quality of the data is the quality of data that we have through the data pipeline. And we will study about data profiling, validation, cleansing techniques, and we will be learning about the testing strategies that are specific to data engineering. And includes integration of data pipelines, testing, unit testing, and now the cloud platform which will cover are AWS, Azure, and GCP. The cloud platforms will be covered, and after this, the projects will be taught. So this was the complete syllabus of the data data syllabus, and the cloud platforms. Is, as I told you, will cover these, and after this, there will be capstone projects which we will be covering also. The capstone project, uh, uh, there are almost two, three to three, 3 to 4 or 5 capstone projects that we will cover. So that when you join any industry, when you join any company, for example, if you are looking for upgradation in your career, and if you join any company as a data engineer, you are well versed with the tools and the skill sets. So I think you might have got the proper idea of what we were teaching, and if you want to join the data engineering course, the big data developer course, you can message us. The big data developer course usually I want you to start from the basic part. So the big data developer opt for the big data developer course, and batches are running. And those who want to join classes can message us on number 9667738426. So I guess I have covered all the topics relevant to data engineering, and hope you get a clear clarity of the data engineering.